our November webinar. This is Stephanie Ryan. I am the Marketing Director here at RapidScale. And this week we have a special guest with us, Nathan Anderson, who is going to be going through some of our disaster recovery, the solution, how it works, and how you guys can take it to your customers and really make an impact in their business. So just a couple of quick housekeeping notes. The presentation will be sent out after the end of it today. We are also recording this session. It will be posted up on the RapidScale Partner Portal. If you do not yet have access to it, please feel free to just let me know when I reach out to all of you later today, and I can make sure that we get you access. It'll be posted by the end of today, so you can go back and reference it, or if you know anybody who is not able to make it, they can go and check it out after as well. So with that being said, I'm going to go ahead and hand it over to Nathan, and with that, it is all yours.
Thanks for having us, Stephanie, and thanks you all for joining today. So what the plan is today, we're going to run through our disaster recovery and high availability solutions that we partner with RapidScale on. And we're going to run through a quick deck, and then we'll get into a live demo scenario and run through the actual solutions in a lab. So as we're moving forward through the deck and through the demo, feel free to post any questions in the chat window or in the questions section, and we'll kind of try to take those as they come. But with that, we'll go ahead and get started. With RapidScale's disaster recovery and high availability solutions, we utilize Vision Solutions Double Take software. It's a software-based real-time replication solution, and since it's software-based, it works on any architecture. So any physical server, any virtual machine running in any hypervisor, and any alternate cloud instance, we can utilize these solutions to protect those workloads from either the ground or any other cloud directly into the RapidScale cloud. So very, very flexible in terms of where we can deploy these solutions. In terms of supportability, we're just looking for a supported operating system to deploy the solution. They are on the Windows side all the way back to Windows 2003 and all the way up to Windows 2012 R2. And for Linux deployments, we support Red Hat and its derivatives, being CentOS and Oracle Enterprise, also SLES and Ubuntu. So a very, very large net that we cast with this disaster recovery and high availability offering. So next we'll talk a little bit more about the actual real-time replication itself. This is a true real-time solution, and it's also asynchronous, so geographic distance doesn't bother us. We can send these workloads across the world if we need to. It's a byte-level solution, so it's very, very efficient when traversing any network. With us being a real-time solution, we're going to be able to provide very, very low recovery point objectives for our customers, a true real-time solution. So quite literally, as those customers are creating Delta from their various applications, we're seeing it in real time and replicating it to the target. In terms of recovery time objectives, we have a sliding scale. So with our HA solution, we're going to have those servers back up in a magnitude of minutes after the declaration of the disaster. With the disaster recovery solution, the recovery time objective is extended based upon how much data we're recovering and also where we're recovering the data to. But we'll dive into a lot more specifics on the differences between the RTO when we look at the lab. We're byte level right out of the box, so very, very efficient, but we've also added compression as well as the ability to throttle that real-time replication. So we can effectively tell this replication technology exactly how much bandwidth it's allowed to use, and we can also schedule those throttles. So a very, very bandwidth efficient technology that's going to be able to work in any architecture over any IP-based network. So the next couple of slides, we'll kind of take a look at how the replication process takes place. So we can see that we have double take loaded on our source machine as well as that target that's in RapidScale. In terms of that deployment of the software, very low level, it's a standard Windows or Linux installer, and we can even deploy that software through our double take console. So we don't have to touch these machines if we don't want to. But once we've deployed the software, which doesn't require a reboot, by the way, when we start these protection jobs, two processes start. The first of them being a mirror process. This is really that initial synchronization of that initial footprint of data. But by default, we do a difference mirror so that pre-staging of that data is fully supported. So if we have a lot of data on the ground and limited bandwidth to send it through, we can take a backup copy, ship it out to RapidScale, we'll paste it into its final destination, and when we start this process of protection, we're going to see that data that's resident in RapidScale and only send the deltas between the two. So nice way to lighten that initial synchronization across the wire. Simultaneously with that mirror process, our real-time replication starts. So as your users are creating delta from their various applications, we see that I/O op on its way to be committed to the hard drive. When that operation is committed to the disk, an acknowledgement is passed back up the stack to whatever application that wrote it to let it know that write was successful. We see that acknowledgement, and at that point, replicate the data to the target and apply it. This is our patented replication technology that maintains write order consistency. So we're effectively replicating all of those I/O ops in sequence to maintain the data integrity on the target side. This means that complex data structures, databases, SQL, Exchange, etc., they're all going to be in a good crash consistent state the entire time we're protecting. We don't have to do anything special to that source data like quiesce it or take it offline to make sure it's in a good state. Our patented real-time replication maintains that data integrity the entire time we're protecting. So when that disaster is declared, we're going to be ensured that we have good integrity on our data in that DR site being RapidScale. Stephanie, this might be a good place to pause. Are there any questions, guys, about the actual replication technology itself?
So I don't have anything quite yet for you. Just a reminder to all the attendees, if you do have any questions, feel free to type into the chat box, to the questions box on the GoToWebinar panel. And I'll be fielding them as we go, and then anything that we need to pass on to Nathan, we certainly can. So it looks like for right now, though, you're good to go.
Perfect. Thank you, Stephanie. So next we'll talk about the various solutions. So for high availability, we use double take availability. With this, we give you granularity with that real-time replication to protect your workload as you see fit. So we can protect at the files and folders level, just data only. Moving up that chain, we can protect applications. We generally see the application level protection deployed on source-side Microsoft clusters. Then we have two available workflows for entire server protection, being full server, which is the one-to-one style of protection, being protecting the operating system, all of the applications, as well as all of the data, barring any exclusions. We utilize this when we have no hypervisor access on the target. So if we have a physical requirement where the target has to remain on a physical box on the target, we utilize the full server one-to-one. Or when we're working into a true public instance where we have no underlying hypervisor access. When we do have that hypervisor access on the target, we utilize our VRA style protection. It's a many-to-one offering where we orchestrate the creation of everything that's needed, including the VMs, disks, etc., on that target side. And we'll show an example of this when we get into the demo lab. But all of these protection methodologies are going to provide very, very low recovery point objectives because we're utilizing that real-time replication. And the recovery time objective is going to be in the magnitude of minutes. So effectively, the declaration of the disaster occurs, a failover process happens, that machine is available to you and your customers within minutes.
Hey, Nathan, real quick, actually, sorry to interrupt. I got two questions for you that I think are good to touch on. The first one that we had come in from Zachary, it says, how is this patented replication technology different than other real-time replication options?
Well, in terms of our real-time replication, we're software-based. So we're utilizing a mini filter driver technology to see that I/O stream as it's coming and send that across the wire. In terms of how we're different, there aren't many real-time replication options out there that aren't hardware-based. So we've been replicating data with this technology for the better part of 15 or 20 years. So it's very, very seasoned, and it's bulletproof. You know, the stuff works. So that would be the big difference between what we see out in the market today. There are some native tools, but they aren't very robust. The monitoring is suspect, and they're just not very easy to work with. We take the complexity out of the complexness of replication and make it nice and easy for you.
Perfect. And the second one, which actually I think is a really great point to touch on here, so I'm glad that it got brought up. If a computer gets a virus or is hacked, is that virus then replicated?
That is a fantastic question, and that is true. So the example that I like to use is SQL Slammer. So if we're protecting that SQL box and SQL Slammer is injected onto that machine, we're going to see those writes and replicate them to the target. So that corruption will get replicated. The way we combat that is scheduled snapshots of that target data. So we can fail over to a point in time prior to that operating system or application corruption. But yes, great question. Thank you.
All right. Thank you. Good to go. Have at it.
Perfect. Perfect. So we'll kind of change gears and talk about the DR solution. I touched on it before. The big difference between the DR and the availability solution is going to be the recovery time objective. So with this solution, we're working in a many-to-one style of configuration. So we're protecting all the physical, virtual, or cloud-based instances that we need to, and we're replicating them to one target server in rapid scale that we call a repository server. So effectively, all those images are stored on that repository server, and at the declaration of the disaster, you would then log into the repository server and create a recovery job that pushes that data to what we call recovery target servers. Those recovery target servers could be provisioned servers in the RapidScale cloud, or you can recover back down to the ground. But since the recovery is happening after the declaration of the disaster, the recovery time objective is extended. And basically that's going to be the amount of data versus the available bandwidth that we're recovering is going to equal the recovery time objective in this case. Another benefit with the DR edition here is granular recoverability. So even if I'm protecting an entire server, I can go back and do file level recoveries. So if Stephanie accidentally deleted a file that she needed 2 weeks ago, we can go back and recover that data. With availability, we effectively have that warm standby entire workload ready to be brought up. So any questions about the differences between the DR edition and the high availability option? Perfect. One of the great benefits about this is that we have the ability to really work in tandem. So for those mission critical servers that require that immediate uptime, we deploy double take availability. And for those workloads that can handle a couple of hours maybe of outage even during disaster, we deploy the DR option. And if a customer workload requires the immediate uptime as well as the granular file level restoration options, they can work together. So you can have a high availability connection simultaneously with a DR connection. So very flexible in that regard. But bear with me here, guys, and let me change gears and open up my demonstration lab. Stephanie, are you able to see that okay?
Yes, looks good to me.
Perfect, perfect. So, guys, in my lab, to emphasize that hardware agnostic capability, I'm working with various Hyper-V virtual machines and ESX virtual machines. So we'll send a couple of these workloads back and forth and do some failovers and some recoveries. But what you're looking at here is our double take console. This is where we manage everything double take. So regardless if it's a DR connection or a high availability connection, it's all done through this console. It's a standalone piece of software. By default, it's going to be installed on the source and the target, but you can load this really anywhere you would want to manage or monitor your double take solutions. But the first step in the process is to add some servers into this console. So you can see I've already installed a myriad of double take servers in my environment, but in order to bring in a new machine, we effectively would just click Add Server. bring in our machine, either IP or name, and once it lands in the console, we're good to go. So if I was just deploying double take on this machine, I'd just simply right-click on it and choose Install. If we were deploying on multiple machines simultaneously, we can also handle that. So if I needed to multi-select and push the install out to multiple machines simultaneously, we can do that very seamlessly. Lastly, in this Manage Servers page, we can create a logical hierarchy. So if you have multiple sites, multiple application groupings, you can create a logical hierarchy here and manage those protection jobs accordingly at that group level. So if you needed 5 servers to fail over for a specific application, you could do that through this logical hierarchy. But with that, we'll go ahead and get started on a protection job. So you can see right off the bat, we're trying to steer the user towards success. Are we creating an HA job, a DR job, or are we performing migration with our double take move software? We're going to work with our double take availability first. And the top options here, protect files and folders and application, or in our case, we're going to work with an entire Windows server. And regardless if you're working with Windows or Linux, it's all done through this console. So the first step in the process here is to select my source machine. I'm going to work with HVRA 02, which is actually a Hyper-V server. I don't think I have enough machines here, guys. Here it is right here. So we'll go ahead and select that as our source. And we're going to work with protecting that into an ESX environment. So I'm going to go ahead and choose full server to Hyper-V or ESX. We talked about the granularity that we give you in terms of protection. So if we just wanted to do data only, we could select specific files and folders that we wish to protect. That one-to-one option when we have no hypervisor to work with in the target environment. Or our full server into Hyper-V, or in our case, ESX. Now, keep in mind that we give a lot of flexibility since we are at that OS level. So even though I'm protecting an entire machine, I can exclude specific data. So we can get very targeted in what we need to protect to save that bandwidth going across the WAN. We also support wildcards in these exclusions. So if you wanted to leave behind all of the music, videos, photos, etc., that your users store, you can certainly get that done. And you can see by default, we're already excluding the page file, very chattery files that we know are not necessary for a successful disaster recovery or HA solution. Trying to make that as streamlined as possible. So we'll go and press forward here. The next step in the process is to select my target server. Now, this target server is just a virtual machine that's running Windows in my ESX environment. It's going to act as my target for the machines that I'm protecting into this specific ESX environment. The next step would be to choose either vCenter or ESX. So we are going to do some orchestration on that new ESX environment in terms of creation of VMs, etc. And we can utilize vCenter to make those communication calls, or we can go directly to an ESXi host. So we don't require vSphere being the target. My environment does have vSphere, so I'm going to go ahead and use that. So next we'll get to our job options page. All right, so you can see here the general tab. That's just what the name of the job is going to reflect inside our double take console. But we are going to create that new virtual machine, and we're going to give you all the options. So the machine location is just where we put the VMX file. It's pretty small, but we give you the choice on where you want it to sit. Next is the machine configuration itself. So we're going to create a replica on that new ESX environment, and we allow you to spec it out as you see fit. So if you need to change the processors, the memory, choose the network adapter, etc. We also allow you to map those source network adapters to their appropriate VLAN in that new target ESX environment. So immediate connectivity once we do declare that disaster. We are also going to create new VMDKs for all the logical volumes coming from the source side, and we can resize these as well. So you can see this system volume is a little bloated, so we'll go ahead and reel in some of that space. You can choose the format of the disk and the data store that each logical volume, each virtual disk will land. So nice to be able to tell each volume where it's going to sit. And then lastly, on the creation of that server is IP. So we realize that a lot of times you're going to be failing over to a different subnet, and we're going to give you options here to add IP address information that's going to be used at the point of cutover. So you have that seamless connectivity. All of my servers sit in the same network. But any questions here about the options so far before I move on, Stephanie?
Excuse me, I don't have anything for you at the moment.
Fair enough, fair enough. One other thing that we're going to do on that target server is create what we call a failover monitor. So effectively, that target server is going to be watching all of those source machines that are protecting to it to make sure that they're up and serving as they should be. By default, after 5 minutes, that's going to trigger a failover condition. But by default, we have wait for user to initiate the failover. This effectively means that someone's going to have to click a button to finalize that process. If I were to deselect this, then whenever this threshold was met, we would automatically fail over. So if we do have the requirement for automated failover, that's built in as well. In terms of that mirror option, we talked about it before. Great way to save some bandwidth on that initial synchronization of that source data. And by default, we're doing a difference mirror. So we're effectively looking at that target data, checking its date timestamp, and if it's different, we do a block checksum comparison on that data to make sure that everything is the same between the source and the target. The network route is the IP address of that target server to which we replicate data. So if we did need to segment or isolate the double-take replication traffic onto a management network or a backup network, we could utilize this routing option here to get that done. I talked a little bit about the snapshots that you can schedule based upon whatever schedule that you would like. Keep in mind the virus example that we gave about that corruption. We are taking some periodic snapshots just for safety's sake. So even if you don't have those scheduled, you're still going to be safe in the event there's a corruption. And then lastly, the networking enhancements. So the compression, on its medium setting, I've seen it get 8 to 1 times compression, but it will really depend upon the types of data that we're working with. And then lastly, that bandwidth throttling. So it's effectively internal QoS. So we can tell our replication engine exactly how much bandwidth it's allowed to use, and we can also schedule those limits. So oftentimes we'll see customers with limited bandwidth squeeze it back during their core working hours and then open it up after core working hours have completed, just so they don't see any interruptions on remote users or offices. But the last step in this process is what we call validation. Effectively, based upon the source and target environment, all of the options that were chosen, we're going to make sure that this job is going to work. If we did see any red error messages, we wouldn't present the finish button. So we're not going to create a job that we know isn't going to work right out of the box. But I'll go ahead and finalize this job. And we'll see it pop up here in my connections here. And effectively what it's doing right now is configuring the target. So you can see it already created my replica server based upon my specifications. Now it's going to create and initialize those VMDKs and start populating them with that mirror data. These are persistent connections, so they will remain through reboot, through WAN outages, etc. Once we establish connection or communication between the source and the target, we will remain to replicate data. So that is really the creation of our HA style of solution. Are there any questions about availability? All right. we will change gears and take a look at the DR protection. So I'll go ahead back to getting started and into the double take DR edition. And you can see right off the bat, a bit of a difference. Are we protecting or are we recovering? So we're going to go ahead and protect in this instance. And I'll go ahead and select my source server here. We also give you granularity with this solution. So if you did just need the requirement for data protection, we can do that, or we can protect the entire full server. Keep in mind, even though you're protecting an entire machine, you're still going to have that granular recoverability. And with the DR edition, we also give you the ability to provide those very valuable exclusions so you can remain as streamlined as possible. Next step, choosing that target server, that repository that's resident in the RapidScale cloud. And you can see a bit more limited options here with the DR connection because there is no failover. So the source name, again, create whatever logical hierarchy or naming structure that you'd like. How we're storing that data on the target is we're going to create a disk structure, a folder structure, server images, and then underneath that, we're going to create a folder for each one of the source machines that are being protected to this repository server. Inside the source folder, we are going to create virtual disk containers for each one of the logical volumes coming from that source machine. We do this for two reasons. Number one, it's very clean in terms of the layout of the data on that repository server. And number two, and more importantly, with those being, all of that data being inside virtual disk containers, we can snapshot at a very granular basis between all of those various source machines that are coming into that one repository server. The options for the real-time replication are all the same, so I'm not going to bore you guys with those. So we'll go ahead and finalize our job. Once again, we validate to make sure that everything is going to work properly. And now we're protecting with both our HA solution as well as our DR solution. You'll have to pardon this, this orphan connection here, guys. I share this lab with 35 other solutions architects around the globe, and unfortunately sometimes they don't put their toys back in the toy box the way they should. But any questions between the difference between the DR solution and the HA solution?
No, looks like we're good.
Okay, fair enough. Well, then we'll take a look at the difference between the recovery. So with our HA solution, once that disaster is declared, we'd simply right-click on our connection and choose our failover button. Now, this button is now grayed out to me because we're still synchronizing for the first time. But effectively, when we click that failover button, we attach the virtual disks to this virtual replica here in our target environment and power it on. So really the recovery time objective is how long it takes your target environment to power up a virtual machine. So really, really quick turnaround. In terms of the recovery process with the DR edition, we'll take a look at that real quick. So we'll go into our DR, and we're looking to recover. So keep in mind the disaster has happened, and we need to recover from it at this point. So we're extending our recovery time a bit. So the next step is to select that image. And if we were working with snapshots, they would all be listed here. So if we did need to go back into a point in time, then we could certainly do that. The next step in the process is to select what we want to recover. So we can do a granular recovery or an entire server. Since we're not fully synced, I'm just going to do a granular recovery. So we need to select what data we want to recover. So this is effectively enumerating that image that's from my repository server. So I'm just going to recover this folder trickily named recovery and add that as an include rule. So this is the data that we're looking to recover. The next step in the process is where do we want to recover that data? we can effectively recover this data to any server that is running double-take DR edition. So any of your source machines that are down on the ground, any server that we prop up inside the RapidScale cloud, or the repository server itself can be used as that recovery target. So I'm going to go ahead and just use my repository server. And next we'll get into our job options here for recovery. So in terms of those options, when we are working with an entire machine, we give you the option to shut down that source machine if it's still running. But if we are just doing a granular recovery, don't want to shut down that source box. In terms of the replication technology, same real-time replication is going to push this data from the repository server to that recovery target. In terms of where you want to put that data on that recovery target, you can choose wherever you like. I'm going to go ahead and send this to the D drive. And we also give you the options for compression and the bandwidth limiting, etc. So we'll go ahead and finalize this with our validation check just to make sure everything's on the up and up. And we're effectively recovering that data while we're still processing the source machine and keeping it protected. So more of a traditional style of recovery process with the DR edition, whereas the HA solution is warm standby. When you have a disaster, that machine is back up in a couple of minutes. Well, Stephanie, that was really all I had to show today. Are there any questions popping up?
So I do have one here for you. It says, during transfer of data, does this provide a potential opportunity for hackers to obtain data?
Great question, great question. And we combat that in a couple of different ways. Now, I know when working with RapidScale, generally they're going to make sure that that connection with your network is very secure. But we also offer the option to encrypt that data with 256-bit encryption. So if you are protecting over open internet link, you can make sure and rest easy that your data is being encrypted prior to being sent and then decrypted once it hits that target in the RapidScale cloud. Great question. Thank you.
Perfect. All right, so with that then, if there are any other questions, now is the time to go ahead and submit them into the question sidebar. I'll give everybody a second. All right, well, it looks like we are all set then. So with that, Nathan, I would like to thank you very much for taking the time to sit down and go through everything with us. If you do have any other follow-up, questions, feel free to reach out to myself or Mark, to our President of Sales, and we'll be more than happy to, set up a secondary call or answer any questions for you. Like I said, I will be sending out the presentation by the end of today. The recording will also be posted on the RapidScale Partner Portal. And like I said, if you have any other questions, feel free to reach out. Other than that, have a great November. A very happy Thanksgiving if we don't talk to you before then. And have a great rest of your day. We will talk to you all soon.